mode, sir.
Yes, yes. Yeah.
Thank you, sir.
So basically, we are going into something called as immersive technologies. Immersive technologies are the next step after game development. In this, we are having three main branches. Combined together, we call them as extended reality. In this, we have VR, AR, and MR. VR stands for virtual reality, MR stands for mixed reality, and AR stands for augmented reality. You might have already heard about it. I'll just give a recap of everything. So in VR, you are having a completely digital world. So you will not be able to see the real world at all. So you will wear a special type of headset for that, and you will not be able to visualize the real world. In the case of augmented reality, it is the exact opposite. You will have a real world scenario. So you will use your phone camera to look at the real world. On top of that real world, you will have some 3D object placed. So that is where augmented reality comes in. Apart from that, we have mixed reality, which is a combination of these two. So I'll show you some examples just to drive the point home. So we'll start with VR. In the case of VR, as I already said, we are having a virtual environment. So you will not be able to see the real world at all. So in this case, you can see the first image depicts an example of a roller coaster ride. So in this case, the user is playing a game where he is teleported to some other environment. For example, he can go to the outer space, he can go inside a nuclear power plant, he can go to anything, anywhere we decide and we program for that. So the user is able to experience something he normally cannot in real life. So that is where VR stands in. You are able to visualize something and experience something in real life that you normally cannot. So in this case, along with that, you can see we are in architecture. So that is for construction workers. So in the case of making a new architecture or a civil building, before actually construction starts, you can experience the entire structure in 3D in real life before you start the actual practical part, so that you make sure that your design looks good, you are not making any mistakes, and you are optimizing your design very well. Same way, you can use the same scenarios in electrical and normal electronics engineering as well. So where this comes in is for practical reasons. So in the case of having any equipment, let's say the students are working with a one-way wiring of bulb. In the first semester or second semester, we usually give them those experiments. But that time, they are not well versed about the use cases of those wires and everything. They might accidentally touch a wire. They may get electrocuted. So there is the danger or else. So your staff has to be always with them. Same with any kind of expensive equipment. Let's say you're practicing a robotics experiment. In that case, the robot will be around a crore or so. So management will also not allow us to buy the equipment for a less price. So they will not allow the students to practice with the higher cost equipment unless until the guidance of a faculty. So in that case, you can have this kind of a intermediate step. After theory learning, they will use this VR learning setup in which you can give them a simulation of all the lab experiments. You actually don't have to buy the lab equipment on your own. Instead, you will have the simulation. In the simulation, the students can practice the one-way wiring, two-way wiring, irrespective of the platform. They can learn any kind of experiment in this. So that is where this VR comes in. Same with medical. So in the case of medical also, there are a lot of simulation. As the field is very sensitive, people cannot just lose their life. So we cannot practice on them, right? So because of that, we need to buy some kind of a mannequin or a simulation tool. So there also we can use VR. Then coming to augmented reality. So in AR, we are having various commercial applications. More than industry applications, most of them are business applications. So in the case of business, what is currently happening is that we are having smart glasses, we are having smart business cards, and we are having clothing showrooms. So instead of using the normal default way of buying any new clothes, which is you have to go into a showroom, try on new dresses, see if they fit you, then you will buy the new dress. Otherwise, let's say you are buying a new furniture for your home, you have to go to the actual showroom, you have to see whether the furniture is good for you, you will buy it and you will place it at your home, which is very tedious. Instead, if you use this kind of a AR application, it will basically track your body, and on top of your body, it will apply some dresses, as you can see here. So you can basically use this application to choose whichever dress you want, and you can directly test it out at your home. You don't have to go to your showroom to figure out whether the dress will suit you or not. At your home, at your own comfort, you can do that. And you might have seen this application already. This is Lenskart. in Lenskart, we also have a try on mode for glasses. So it will basically scan your face, and based on your face structure, it will suggest you the best glass frames and style. So this also you can order it from the application itself. You don't have to go to a Lenskart showroom. You will buy it online. You will receive the glass at your home. And many of you might have seen this as well. These are face filters. Face filters also technically come under AR application only. So these are just for fun, entertainment. Apart from that, we have these business cards. So in the case of business cards, traditionally the normal business cards will have the company logo, will have your profile name, then it will also have some details about yourself, right? So what you can do here is, instead of having to, talk about your business card yourself, you can have a business card that will talk about you for you. You are not going to talk about it at all. Instead, you will have an animation. This 3D model can be yourself. So you will talk about yourself in a 3D format, and you will have these buttons. There is a button for your social media, your LinkedIn, and any kind of WhatsApp number or contact. You can put it in there. When the user presses the button, automatically they will be enabled into your contact. So you don't have to do it manually at all. And this one is the most common application of AR right now. We call this as marker based AR. I'll explain what it does in a bit. So basically what is happening is, in the case of let's say in the kids studying for a biology exam, let's say they are studying in 10th standard, they have their science exam, they need to learn about the structure of the human body. They will learn about the heart structure, lung structure, the structure of brain, so on. So for them, when you're learning about it, you will not know the internal structure of everything. In the case of engineering applications as well, for motors and refrigerators or any kind of machinery, we don't know the internal structure of it. What we do usually is we will have a cross-sectional diagram, but the diagram is not very easy to learn with. It will just give you one single view of the particular object. So instead, what we are doing here is we will have one QR code. When you scan that particular QR code, a 3D model will come. So this 3D model can be the 3D model of a heart. It can be the 3D model of a motor, whatever it is. Depending on your application, you will have any kind of 3D model. Inside that 3D model, you will be able to visualize all the parts. You can interact with it. You can make it bigger. You can make it smaller. You can rotate it. If you want, you can move it around, right? And you can have interactive chat with it. So basically, if you have some questions about this model, if you tap on it, it will give you some details. It can also be integrated with any kind of AI chatbot. So it is a much better learning environment for the students than just looking at a page with some images. So that is where this AR comes in right now. And we also have jewelry try-ons. Here you can see, similar to the clothes try-on, this is a jewelry try-on application. It can be used for watch trying-ons. Then you can have it for any earrings, nose rings, all those things. All those things are possible with AR, right? So finally, coming to mixed reality is very similar to augmented reality. There is only one slight difference between them. So in this case, for augmented reality, you are not interacting with anything in particular. That is, you will tap on your screen, obviously. If you want to press a button or you buy something, you will tap on some buttons on your screen. But apart from that, you are not physically touching the virtual objects. The virtual objects are not interacting with you. They are just superimposed on top of your body. So you can see here clearly. So this glass image here, the glass image is not actually there, and it is just being superimposed on top of the face of this girl. So that is augmented reality. In the case of mixed reality, what happens is, you can see here there is like a overlay. The person is trying to play piano. When the person is trying to play piano, there is a overlay on top, and in that overlay you can see various colors and everything, and it will teach them at what timing they have to press the keys. So they are trying to learn piano using augmented reality. But we call this as mixed reality because when they do something in real life, the application will change its state. So you can see here, when they press the button in real life, the virtual buttons, the virtual keys are changing. So they are interacting with each other. You do something in real life, something in the virtual object changes. So that is what we call as this thing, mixed reality. Okay, so that is the only difference between this and that. Apart from that, AR and mixed reality look exactly the same. So you can see the entire environment. In the environment, you can see some virtual objects. Same way in AR also, you can see the real objects. But inside mixed reality, whenever there is some interaction between the real world and the virtual world, we call this under this domain. That is the only thing. So we can see multiple other examples as well. In the case of a medical field, so we have a implant here. So for this implant, before you actually manufacture the implant according to the size of the patient, you can have a 3D model of it. Use this kind of specific headsets called Meta HoloLens or Meta Quest, any kind of particular headsets. And using this, you can visualize the bone structure. You can visualize the structure placement and make sure that you're actually making the correct part, basically. And the size and dimensions you have measured correctly, probably. All those things can be ensured before you actually go into the practical mode. And here the final example is for constructions. So when you're doing some sort of construction, you will be able to visualize whether the actual part you're trying to place there will fit inside that area. You have enough empty space or not. If you're trying to do some construction, you have to ensure that before you start the construction. Otherwise, everything will be a loss for us. Yeah. So these are the major examples in AR, VR, and MR. We will go into them in depth, and I'll show you some demo videos after this. So yeah, coming to the devices, in VR, we have specific type of headsets. So there is two different modes of headsets. One is standalone headset and another one is tethered headsets. Standalone means they will run without any connections, similar to your mobile phones. You are not connecting your mobile to anything, right? Your mobile itself has a processor, RAM, storage, everything. So you can use your phone itself on your own. Same way, the headset also can be used on its own. You don't have to connect it to anything. So that we call it as a standalone headset. Nowadays, the industry standard is standalone headsets only. The most recent headset that was released is Apple Vision Pro. This cost around 4 lakhs. And the most consumer friendly models are MetaQuest. MetaQuest 2 and 3 are the ones bought most frequently. And MetaQuest 3 cost around 50,000. MetaQuest 2 cost around 25,000. The Pro version has been discontinued right now, so it is not able to be purchased anymore. Then in tethered mode, basically it is the opposite of that. Standalone means you don't have to connect it to anything. In tethered, you have to connect it via wire. As the name implies, tethered, you have to be connected to the computer by using a wire cable. Okay. So in this VR mode, on the tethered mode, you have to use a C2C cable. So they will give you one C2C cable along with the headset. And what will happen is your application will be run on a computer. For example, you think of a projector. Right now, if you're projecting something onto the screen using a projector, the PPT is not running on the projector, right? The PPT is actually being loaded on the computer using a laptop or a desktop. And from there, you're using a HDMI cable to project it onto the screen. Same way, the third mode means you will have one computer on which the application will get executed, and that output alone will be sent to a VR headset. Okay. So in tethered, processing is done somewhere else. Output is seen on the headset. In standalone, both the processing as well as your output is seen on the same headset. So why do we have these two things then? So in the case of a standalone mode, because it is similar to our mobile, you can install applications on it, you can play games on it, you can watch videos on it. All those things are possible. But the problem with that is because it is a limited size, you don't have much processing power. Similar to your phones only. If you buy a phone for 25,000, the same amount of performance only you will get from this standalone headset. If you try to make a very big application, it will lag. You cannot play it properly. It will not run at all properly. So we don't want that issue here. In that case, we go for tethered mode. In the case of tethered mode, what will happen? Because you are using a computer, the computer has much better graphical performance, right? You can use any sort of NVIDIA GPU or AMD GPU to get much higher performance from your computer, and the output alone you will share it to the headset. So that is why we go for tethered mode. If you want better quality, you go for tethered mode. If you want better portability, so you want to walk around your room, in that case, you go for standalone. Because obviously, if you are using tethered mode, you need to use a wire. And if you are connecting yourself to your computer, you can only walk around the range of the wire, right? If the wire is very short, you cannot walk very far away. That's why we prefer standalone for portable applications and tethered for high quality applications. Right. But the development wise, both of them are same. You are not going to develop different applications for them. Development is exactly the same for both of them. The end use case or the usage will vary based on your application. You can use it standalone or tethered based on your use case. Then we have the AR devices. So in the case of AR devices, you don't need a particular type of headset for it, but in VR, you need a special headset. That's why VR is much more expensive than AR. In the case of AR, you can just use your normal mobile phones as well. You don't need a special headset. You can use any kind of normal mobile. If it is a recent mobile, it will work very well. If it is an old mobile, it may work or may not work. Right now, the limitation is Android 10. If you are having mobile with Android more than 10, you can use that. So latest mobiles like Samsung Galaxy S24 Ultra and tablets like iPad and Samsung Galaxy tabs will be useful here. Then we have our Microsoft HoloLens. So this is a advanced mixed reality headset. This can be used for AR as well. Kindly make a Srinivas sir, kindly make a So we have a HoloLens and Magic Leap. Both of them are AR headsets. They can be used for mixed reality as well. They are again very expensive. They are around 2 lakhs each. And they are not much used in the industry right now because, as I said, mobiles are the easier way of going for AR. Okay. And in this example here, you can see this image. The first one is the Apple Vision Pro. And this one is the Meta Quest 3 on the right hand side. The white color one is the Meta Quest 3, and the black one is the Vision Pro. Below that, we have the Valve Index and HTC Vive Pro. And finally, the last two are your HoloLens and Magic Leap. Apart from that, we have the tech stack now. So how these actual headsets work? So for that, we are using something called a SLAM. You might have heard about it already. It is a popular technique in robotics. So using this SLAM technique only, the headsets basically figure out their way, where they are standing, where the user is standing, whether they are walking forward, backward. All those things are calculated by using the SLAM technology. So this is basically a technology or an algorithm used in robotics that is being implemented inside AR and VR as well. I'm not going to go into much depth into this because there is not a requirement for learning this. Just know that it is the backend technology that runs all the AR and VR devices. Apart from that, we have hand tracking. So inside hand tracking, as you can see, usually when you are using a VR headset, you will need a controller similar to a remote. Whenever you are operating a TV or something, you need a remote, right? Same way for the VR headset also, you need a remote or a controller. But recently, we are having cameras. Those cameras are able to basically scan your hand and it will track your hand automatically. So you don't have to manually do it. So this is where this kind of hand tracking system comes in. So next we can see the stereoscopic displays. On stereoscopic displays, so the way the VR glasses work is called as a stereopsis. So this is what we use for basically, showcasing the user in a 360 video. Normally, when the user is seeing something, you will experience it on a screen, right? So the same screen will be used inside the VR headset, but instead of seeing through that screen, you will have two lenses. Those lenses make your vision basically, what do you say? You are basically being what to say? You are basically having some illusion. In that illusion, it makes your brain feel that you're looking at a 3D image. So for this, we use an effect called parallax effect. You know how when you close your one eye, some objects move to the left or right. When you close your right side eye, the objects move to the left, and when you're closing your left eye, the objects move to the right. So I'll give you an image to example that, this one. So when you're using a single eye to look at some things, you will not be able to see the depth information, right? The same way in your screen also, that is why you are not able to see an depth information. When you look at a photo, you cannot tell who is standing in front, who is standing at the back side. So in that case, we will use something called as this stereoscopic displays and use two lenses. Those two lenses look at the same image from different angles, similar to our eyes. Our eyes have a distance between them, no? You depending on the person, there will be like 5-10 centimeters of difference between your eyes. The same way, we are simulating that using two screens. So inside the VR headset, there will be two different screens. One screen is for your left eye, one screen is for your right eye, and you're looking at them through one particular lens that makes it feel like you are looking at a 3D image. And coming to the software development part, we are having two main softwares for this, Unity and Unreal Engine. Apart from that, if you want to write code on your own, you can write that as well. Unity and Unreal Engine are game engines. So primarily they are used for making games, but they have the features for doing AR and VR development as well. Because as I said, game development is the primary basis for AR and VR. After games only AR and VR evolved. So because of that, all the game engines will be used for AR and VR as well. And in this case, Unity is used mostly in the industry because of its widespread features, and Unreal Engine is used whenever you need a higher quality. Apart from that, you can see there is ARKit and AR Core. ARKit is for iOS, AR Core is for Android. So this ARKit and AR Core are specifically used when you want to program it on your own. So these game engines will do majority of the work for you, but if you're using ARKit and AR Core, you have to program everything manually. Then there is WebAR. WebAR basically means your application will be executed on the browser itself. So you don't have to install any application. So your AR application can be opened from any browser. So I think game engines, you might have already seen it. So the game engines will do these things for you. You don't have to manually do every single step, as I told you. Instead, the game engine will do these things for you. That is first one, input handling. So you don't have to check for all the keyboard inputs. The game engine will do it for you. How long the user is pressing a button, whether they released the button or not, or they're tapping the button, whether they are using their finger to touch it or mouse to touch it. All those things Unity will take care, or any game engine will take care. Same with gameplay logic. So you will write your actual game scoring logic only. Apart from that, everything the game engine will take care. Then we are having physics engine. So whenever you are making an application, you need the physics to feel as realistic as possible, right? If you throw a ball up, it should come back down. It should have gravity. It should also have some sort of what to say, friction, drag, air resistance. All those things are required, right? Then only it will feel very immersive. All those things are by default inside Unity. You don't have to program anything. So that is the advantage of going for a game engine. If you're not using a game engine, you have to manually program every single of one of those things. Then we have audio. In the case of audio, there are two types of audio. One is 2D audio and one is 3D audio. So 2D audio in the sense, you think of it as like a speaker system. Wherever you are, you will hear the audio, irrespective of volume. If you're close to me, you will hear it at full volume. If you're far away from me also, you will hear it at full volume. That is called as 2D audio. 2D in the sense everyone in this world will hear it at the same audio level, same noise, same intensity. In the case of 3D audio, it is similar to real life. If I'm standing close to you and I'm speaking to you, you will hear my audio much higher volume. If I go far away from you, then my voice volume will reduce, right? The same way, Doppler effect, all those things are available inside Unity by default. You don't have to program anything for that. Then animation and rendering is there. Animation and rendering you can group together as a single one. They basically tell how to draw the 3D objects onto your screen. Right now you are seeing the image on your monitor, right? Whatever I'm being casting here is being shown to you via the internet, and your monitor knows to display every single pixel. That process, how to display these images onto your screen, is called as rendering, and that will be taken care of by Unity itself. Animation in the sense, you would have seen some animation movies, Disney movies, kids movies, that thing only. All the character animation, how they are walking, how they are moving naturally, all those things are done inside Unity by itself. So you don't have to do a lot of coding for that. So these are the popular game engines, out of which Unity is the most predominantly used one. Then we have Unreal Engine. Apart from that, we have Godot Engine. Godot Engine is one of the open source community versions. So it is very easy to use as well as free. There is no licensing fee for that. GODOT, Godot Engine. So coming to the limitations of game engine, Because game engines are integration tools, they don't have any implementation or they don't have any kind of creation tools. So let's say you want a 3D model, you have to use some other software like CAD or something to actually create your 3D model. You cannot do it inside Unity or any engine. Same with editing images, editing audio. You have to create your audio file and image file somewhere else. You cannot do it inside Unity. And coding as well, you need a separate integrated development environment or IDE. You cannot type your code inside Unity. You have to use a separate software. So then why are we going for Unity specifically? In the industry, we are going for Unity because of these reasons. First one is cross-platform support. That is, we are not limited to Windows only. We can use this software on Windows, Linux, and Mac. Irrespective of the platform, you can use it. Then community, because Unity has been around for around 22 years now, there is a lot of support and lot of resources available on the internet. You can use them to learn. And asset store. So we will see about this in detail in a bit. I'll show you how to use this asset store. What we are going to do is I'll show you how to import some 3D models from the asset store, because everyone has to learn about the 3D modeling phase. If you are wanting to work with AR and VR, you have to know how to create 3D models, how to program, as well as how to develop your actual environment. So for these things, obviously everyone cannot learn everything. So we have this tool called Asset Store. Inside Asset Store, you can basically download things in which we are weak in. So let's say you are weak in creating models. You don't know how to 3D model, or you don't know how to program well. In that case, you can go into this website. You can download any 3D models. You can download code files. Or if you don't know how to create audio, you can download audio file also. All the things will be collectively kept there at the Unity Asset Store. And it is maintained by Unity themselves. Apart from that, you have the documentation. This is where you are getting the code files. So all the code files and everything will be there in the documentation. In case you are confused about a function or something, in the documentation part, there will be extensive examples about every single thing so that you can learn it easily. And finally, the most important one is flexibility. Even though Unity is primarily used for games, it can be used to make 2D applications, 3D applications, AR and VR applications, mixed reality applications. Apart from that, it can even make applications for your smartwatch, smart TV, anything. Literally any hardware on the planet, Unity can make a game for that. Right. So these are the popular games made in Unity. So coming to the actual industry applications now. So we will start with digital twins. Before that, let me just check the chat messages. In case you have any queries, you can ask me. So yeah, Panorama 360 degree is the same as 360 actually. There is not much of a difference between those things. Panorama is a way of capturing 360 images. Using your phone, you can try to capture 360 images. That is called panorama, but it will not be exactly 360 degrees. If you want exact 360 degrees, you need to use a special hardware for that. There are separate 360 cameras for that. They will cost around 10 to 20,000 rupees, and they will give you a different sort of image. They will not be like the normal panorama image. So Cartoon Engine, CryEngine, these are all different game engines. So what will happen is basically whenever a company wants to make a new game, no, they may decide to use already existing tools. For example, they may decide to use C++ or C, or based on their requirement, they will create their own engine. One such engine is the CryEngine, Rage engine. You may know about Grand Theft Auto, right? GTA games. In GTA games, they have their own engine. It is called as Rage. So like that, various companies use their own engines. And yeah, Unreal Engine and Unity recently collaborated, and they collaborated for a different reason. It is not about their application. They wanted to basically collaborate related to the payments. They wanted to make the payment features for developers very easy. That's all. Their entire application is separate. They are not related to each other. Right. So let us go back to the part now, applications. So we'll start with the digital twins. So Unity clouds, in the case of Unity cloud, there are two types of cloud actually. In Unity, you can use something called Unity version control. It is similar to GitHub. So that also people call it as cloud. One more cloud is project storage, basically. So whenever you are having some sort of a new project, you can upload it to the Unity cloud. Only when you do that, you will get access to features like monetization, ads, all those things. Whenever you want to use any sort of online feature, you have to use Unity cloud. For collaboration purposes, you have to use Unity version control, sir. You have something called as Unity version control. Inside that, you will get the features for working together on a project, basically. It is similar to GitHub. You will push your changes, pull your changes. All those things are possible inside Unity version control. But that version control is an online feature that will work only when you enable Unity Cloud for your project. It's a free feature, sir. So there is a limitation on that as well. Unity is not completely free. We are using a free license basically. For educational purposes, Unity is free. If you are trying to make money out of it, you have to get a license. If you make 10 lakh dollars within a year, then you are supposed to update your license. You are supposed to buy license to Unity. The score updated and store on Unity Cloud. So you there is a Unity leaderboard feature. If you want multiplayer for your game or something, you can use leaderboard features inside Unity. So for that also, you have to use the Unity Cloud. You have to log in with Unity Cloud. Only from that, you will get the access for that. By default, it is not enabled. You are supposed to use it only if you need it. So yeah, now coming to the applications. As I said, we will start with digital twins. So I want to show you a different PPT for that. Right. So you might have heard of this term, digital twins. So what is a digital twin basically? It comes under a industry 4.0 concept. Right now we are trying to implement this in India. So it is basically a twin as in a replica, a copy. So a digital twin stands for a virtual copy or a virtual replica of a physical object. So you think of anything in real life. If you're having a water bottle, a 3D model of the water bottle can be called as a digital twin because it is the exact same. Same way, it can be anything. You can have any system, object, or a process that receives real-time data and it is trying to copy the real-time behavior into the simulation. So I'll show you one example here. There is a video here in which there is a random apartment with multiple doors, and we are trying to basically simulate how fire may spread. So that in the future, in case in real life there is a fire, we can see where people will get stuck and we can help them easily. So we are trying to optimize the rescue part of the fire operation by using some simulations. So you can see here, when I press the play button, they are using the amount of people slider, 28 people right now. And when they click on start simulation, the people are randomly walking, fire spreads over here. You can see the fire starts at a single point and it's starting to go into different rooms. So because the fire is going, some doors are blocked now. And a couple of people are stuck basically. This guy is not able to escape anymore and he's got stuck in this room. So by doing this simulation, you know right now that because of this fire, this person gets caught. So you can basically put a fire escape there. This is how you do design, design optimization. Yeah. So they have given you how many fatalities may be there, how to improve your design, all those things you can infer from this actual simulation. So you can design any sort of room here. This is just an example of a basic room. And you're having some camera feed data to get the details about which person is walking in which area. You will have some IR sensors and any kind of fire alarms if you want. And all those things can be together grouped as a single system. And that system can be replicated inside the simulation in Unity. So yeah. So why do we go for digital twins then? The primary use of digital twins is to save time as well as money and increase the safety of your application. It can be a building, it can be a car, whatever it is. Irrespective of it, the use of digital twin is to reduce the cost, reduce the time of deployment, and increase your safety as much as possible. So in the case of the building, as you can see, if you are able to figure out where the fire starts and how it spreads, obviously you are creating much higher safety for your department or a building. Apart from that, you are also increasing the likelihood that there is no fire damages. If there is no fire damage, you are increasing your revenue, as well as you are not losing anything on the breakdown. So for this, we have to do three things. We have to simulate our twin, and based on the simulation, you have to analyze your results, and then finally you will do some prediction. The prediction is what actually solves your issue. So when you're doing the analysis based on the data, you will know, okay, this person, whenever they are standing in this room, they will get caught in the fire. So in that case, let me put a fire exit, or let me put a water bucket, let me put a fire extinguisher there. So it is easier for them to escape that room. All those things. So what we are getting from a digital twin, we are getting real-time monitoring, unmatched visualization. So if you are using a IoT for this, you will obviously not be able to see any sort of 3D object here. Instead of 3D object, you will get one graph. The graph is not very immersive, right? So that is why we are having this kind of digital twin. And we are able to do two more things. One is optimization of operations. So any kind of operation, when you're doing it here, you will be able to optimize it as well as possible. Then finally, we have the predictive maintenance. So in the case of predictive maintenance, before breakdown happens, you know that some breakdown will happen and you are going to stop the process and fix it as soon as possible. So this is being already done by BMW and some luxury car companies. What they do is they have a tracker and a digital twin of your car, and in that digital twin it will basically tell them how much tire pressure you have, how good your tank condition is, how good your engine condition is. All those things they can monitor from their showroom itself. You don't even have to visit their service workshop. From their workshop itself, they can see whether your car will have some issues or not. And if your car condition is not good, they will call you before the car breaks down. They will call you a week back, and they will tell you within a week you have to bring your car to service, you are having some issues, and they will fix it for you before you actually get a breakdown, so that your time and money is not wasted. Yeah. So coming to the applications, these are the primary use cases of digital twins. Architecture design visualizations. Obviously, as you can see, before you construct something, if you are able to look at it, it will be much more impressive for the management as well as the administrative powers, so that they can easily get more investment into this. Then we have collaborative design systems. So let's say you are working on a new car or something. If you're designing something, you have to look at it through the 3D models. In the 3D models, obviously, if you're looking at from a point of perspective, this next person cannot look at it from the same angle. They also have to download the same model. They have to open it in their system. Then only they can see it. But instead, if you have a VR digital twin, you basically can bring the 3D model to real life, and you can look around it. You can interact with it. You can do various things with it. Same with product configurator. So I'll show the examples as well directly. So this is a collaborative digital twin. So as you can see, there is no real life car over there, but they are using this VR mode to basically work with the digital twin. They are able to see how the car is designed, what are the parts in that, how to actually improve the design. All those things are visible inside. So he's connecting the real world hardware to the virtual twin, so that whenever he moves it in the real life, the virtual twin also moves. So this is the example of a collaborative tool. So that is one. And this is a product configurator. This you might have seen it already. This is the basic digital twin. So when you're trying to buy something, you might find some 3D models online, right? So those 3D models also, technically they are considered as digital twins. They don't do anything. They just showcase the product to you. They are level 0 digital twins. We have various levels of digital twins. I'll show that to you next. But before that, we'll complete all the examples. And this is the example for architecture visualization. Before construction of a cafe or something, you can see how the environment will be, how it should look, how the lighting will be. All those things can be simulated inside Unity before you start the construction process. And the final one is large scale simulation and testing. Let's say you're building some kind of a big industry. You want to know how much power the industry will draw. You want to know how much water will be used daily and how many people will come in and go. You want to basically optimize your parking lot. All those things you want to do, right? It is not possible to do it within any kind of software. So for that, you come into Unity, and inside Unity, you basically create the entire environment. You create all the people, create all the cars and everything, and you let them do anything they want. Based on that, you have some simulation data, and you analyze that data, based on which you draw some conclusions to optimize your design. Again, that is the overall workflow. You simulate something, you get some data back, you optimize based on that data, and you do the actual implementation. So technologies that you need for a digital twin. The first thing starts with electronics. So you need to know about IoTs and sensors because you need to get some real world data, right? So in that case, you need to learn about electronics. You need to know at least the basics of this thing. Then comes big data and AIML. So now you know to get the data from sensors, and instead of just showing it in a graphical manner, you need to show it in a 3D models. That is what a digital twin is. So for creating the 3D model, you also need to know about Unity. Apart from that, you need to know about 3D modeling. You need to know either CAD modeling or game development modeling. If you learn those things, then finally, for creating the data inference, you need to know about some ML models. If you learn about the basic ML models like forest or any kind of aggregate system, the basic ones even will be enough for creating some kind of inference from the data. After you get the inference from the data, you can use big data storage, you can analyze them, you can store it on the cloud, whatever it is. So this is a combination of multiple domains of engineering to get the most efficient visualization possible. So coming to the components of a digital twin, we have two things. One is a physical asset. Physical asset in the sense it is the hardware. So you will have the sensors, actuators, all those things, and you will have the controller. And the software is where your digital twin actually works. So this is Unity. Inside the Unity, you will have the digital twin. And from that data, you will get the analysis. Connecting these two things, you have the middleware, which is the server. So similar to your IoT, ThinkSpeak, or Blink, or any kind of a data network, storage servers, you can upload your data from the hardware to the server. From the server, Unity will read the data and it will do the simulation for itself. So this network devices can be any kind of network communication. You can use Ethernet, you can use Wi-Fi, you can use Bluetooth, whatever it is. Depending on your application, depending on your range requirement, you will use various networking technologies. So this is one example for a digital twin using a car. So we have the car over here, which is the physical asset. They are connected using a cloud, and you will get the real-time data, sensor data. It can be the car speed data, it can be the steering wheel data, it can be any kind of data from the car itself. And those data are transferred using the internet to a 3D model. The 3D model has to be designed by someone. You can use any kind of data analytics, AML models. You will do some kind of predictive simulation, and you will try to figure out what is the most likely way this car will have some issues. And based on that simulation, you will do some predictive maintenance. So after that, we have the levels of digital twin. We have 5 different levels of digital twin commonly. The first level is descriptive twins. So in the case of descriptive twins, as the name implies, they will describe something. So I was giving you an example for 3D models, right? So that is the most common example. So you can have a 3D model of something and that exactly shows the real world part. So that is a descriptive twin. You think of your house plan. Your house plan is a descriptive twin. Any kind of house plan that is in 3D exactly shows your real house in 3D. So that is a descriptive twin. Then we are having diagnostic twins. So in the case of diagnostic twins, you will have some real-time data, and based on that, you can perform some analysis. So in this case, the example I showed you now for the fire simulation, that can be considered as a diagnostic twin. So you will get some sensor data, and based on that, you can do some reports. Then comes predictive twin. So predictive twin is where actual digital twin starts. So this is where your high level twins are there. In predictive twin, you do some operations, you do some simulations, you get the data. From the data, you are trying to identify some potential issues. You're trying to solve something basically. So you are having some issue and you're simulating that issue based on which you are trying to find some inference and find the optimal outcome. So that comes under predictive twin. And prescriptive twin, it is the one more higher level of twin, which will automatically try to solve your issue. So based on whatever you give the data, it will try to solve the issue and it will try to suggest you the best outcome. Then finally, we have the autonomous twin. This is the highest level digital twin that is possible right now. And the most common example for this is a self-driving car. So the self-driving car doesn't require you to be there. It can do the best outcome and best decision making on its own. It has tons of data stored using big data, and it is able to take the data, have a good AI/ML statistical model based on the data it has and the sensor data it receives from the lidars, from the cameras. All those things combined together, it always makes the best decision for the driver and the car. Yeah. So for the digital twin, creating a digital twin requires various steps, as I told you. The step starts at 3D model creation. So whatever you want to create, you need to have a 3D model for that. So you can use any CAD tools, as I said, if you're comfortable with Fusion 360 or SolidWorks, whatever it is. You just need to create a 3D model of it. Once you are done with that, we will optimize that model so that it is not lagging inside the application, basically. If you create a very high quality model, Unity will lag. So we have to optimize that part as well. Then we will go into the Unity software or Unreal Engine based on whichever software you are going to use. And you will design your application over there. Your simulation logic, you will code it everything over there. And you will integrate it with the IoT data. As I said, you can use any kind of IoT service. You can use Blink, Firebase, ThinkSpeak, whatever it is. Here I've given the example as AWS and Azure. Everything is possible. You can use whichever one is comfortable for you. Then finally, you can you can do the analysis using Python or any kind of statistical tool. Here I've given the examples as Tableau, Python. So all this is possible. Yeah. Now coming under the digital twins reason for using Unity, the same way. We are having cross-platform support. We are having the real-time 3D rendering in physics. So you don't have to code that much. Then because Unity uses a language called C Sharp, it is a language built by Microsoft, and it is very easy to use compared to the previous languages like C and C++. It is having the syntax like C, but the features of Java and C++, everything else also will be there. So it is much easier to use than other languages. If you want, you can use visual coding also. If you are not comfortable with normal coding, visual coding is also possible inside Unity. So you can just drag and drop boxes, connect them using wires. That coding also is possible. And asset import support. This I will come back to later as well. So if you're not comfortable with 3D modeling, as I told you, you can download 3D models from the internet and use that. There is no fixed way of creating your own 3D model. You can use any 3D model that you find on the internet and import that and use it here. I hope you can hear me now. Sorry for the disconnection. Yeah. So this is the actual Unity's office building. And in that you can see now, you will get all the internal cameras and sensors, everything. If I just select on any one of the camera, you will get the 3D view of that. So this is a 360 camera. You can see all four directions. Whichever person is walking over there, all those things can be visualized over here. So this is an example of digital twin in real life. So they are having their entire office building 3D modeled. You can see all the tables, furniture, everything inside this environment. You can choose all the door locks as well. So this is the card reader. So that is the main use case of digital twins. You are able to operate it remotely. You are able to do some sort of analysis from remote, and you can optimize your design as well as you could. So you can see here, these are all live data, right? So this is where this digital twin comes in. So apart from that, we are having a couple of challenges with digital twin as well. We will start with the basic ones. Obviously, because it is a digital twin, you need to have some sort of initial investment. you need to put a lot of initial cost because of the 3D model requirement, the server requirement, as well as integration of all those tools. Then, because you are using some AI ML models, you need to care about the data quality as well. If your data quality is bad, your analysis will be bad as well. And because of using various tools and technologies, integration also will be a hard thing. Combining various domains and departments of engineering will require a lot of technical expertise. And finally, the security and privacy issues. You kind of need to use any cloud providers. And if you are using any cloud provider, obviously you cannot guarantee your data. And finally, the technology dependence, the redundancy requirement. So as I have already told you, if you are having some kind of AI model, you need to upload it to some cloud models. And when you are training your data on that, you need to have some backups based on which you can or cannot trust that entire source. If you want to keep everything offline, let's say you want to store your data, everything inside your college campus itself, obviously you need to build a lot of servers. And because of that, your investment will go much, much higher. So that is why digital twins are not largely implemented. The initial cost and the requirement for the expertise is much, much higher than other applications. So that is it about digital twins. Is there any doubts related to that? If you want to build a multiplayer FPS game, yes, you need a server for that. Digital twin is linked to microprocessor. It is kind of linked, I guess. You can use any kind of microprocessor or microcontroller to get the sensor data. PPT, I'll check with ma'am and share you. Then we are having 3D models. Okay, so 3D games, you can post it and place it, or you can just search for some YouTube videos. It will be easy to do that. You need to buy a developer license for that. And after that, you can use your own Gmail ID to publish it there. It will be the similar process to itch.io. You just need a license for that though. Yeah. So is there any other queries related to digital twins? Right. So we'll go into the next applications. Film and animation, architecture, visualization. So for these things, I'll just show you some videos. You'll get a better understanding of those things. Apart from that, yeah, I think we'll start the demos now. I'll show you the things after that, PPT. Yes, digital twin is playing a crucial role in this industry right now. So yeah, I can show you some of the tools and techniques that we use in VR and AR. We'll start with that, then go for the demo videos. So for VR, till now, what we have discussed is the type of headset we use. And in that headset, I can show you what are the tools actually being used there. The first one is the head mounted display. So whenever you are using a VR headset, you will have one thing that will wear it on the head. We call that as a head mounted display. On that only, you will have the lenses. As I told you, you will have the stereoscopic display. Then we have the input device. The input device depends on your application. You can either use your hands, you can use your controllers, or you can use your eyes also. The eye-based tracking is called as gaze tracking. It is one of the most advanced features. It will just track your eye movement, and based on wherever you're looking, you can press and click buttons. You don't have to use your hand to click on them. Then we have tracking system. So the tracking system, we call it as inside out and outside in. I'll give you an example for that. So you can see here on this image, inside out and outside in tracking. So inside out basically means your camera is attached on the user itself. So whoever is using the VR headset, they are having a camera on top of their head basically. The VR headset itself will act like a camera, and it can rotate and see the entire environment. So the camera itself will track the user basically. In the case of outside in tracking, you need a lot of cameras pointed at the user, and based on that, you will be able to track the position of the player inside a particular room. So the entire camera setup will be covering the full room. So if it is a big room, you need a lot of cameras. So outside in is a bit more expensive, but inside out, you can use a single device. So the normal VR headset, it will also have a camera and a GPS sensor, and based on the GPS data, it will track where you are going and everything. Recently, every single setup is being done as a inside out camera only. No VR headset in the recent times is coming as outside in. Outside in was the technology used a decade back. Recently, everything is inside out technology only. So apart from that, we are having spatial audio. I've already talked about spatial audio a bit. We are having the 3D sound effects. So those things are all possible within the VR headsets itself. You don't need a separate headset for that. Then finally, we are having the VR development engine. For that, as I told you, we are using Unity. So coming to the types of AR interactions, we are having these four techniques. Marker. So what you can think of these thing, your AR application. In VR, there's only one way of implementing a VR application. That is just using Unity. There is no different types of VR basically. In AR, there are types of AR. The application itself can be considered in various methodologies or various techniques. Those things only we are going to talk about now. The first one I have already shown you, that is the marker based AR. You will scan something, and based on that scan, you will get a 3D model. The scanning thing is called as a marker. The marker as in the indication. You are going to point your camera at something, and based on that, something else will happen. So the ID card, it can be anything. It doesn't have to be a QR code. If it just has to be a JPEG or a PNG image. If you scan that image, you get a 3D model. So along with that, you can see the examples as business cards. You can see the previous example, the book QR codes. If you want to study about some 3D part, let's say you scan a image and you get a 3D model of a motor, you will learn about the motors and parts and everything, how it works, all those things. So those kind of applications come under mark. Then we are having the markerless AR. In the case of markerless, you think of your Amazon application having a product viewer, AR ground. It will scan the table or any flat area, and when you tap on that, it will automatically put a object that you are trying to purchase. So if you want to buy a new phone, you go into that AR product viewer and you tap on the disk. It will bring that actual phone in front of your disk, and you can see what is the size of that actual phone, and you can look at your environment and see how big it is. Markerless. Marker based means you are scanning something in particular. In markerless, you are not scanning anything. Automatically, it will detect any flat areas. The flat area can be vertical as in it can be any walls, or it can be horizontal also. Horizontal as in the sense, it can be a disk, it can be ground, it can be anything flat. That's it. Then we are having projection based AR. In the case of projection based AR, we are using no screens basically. This is not a commercial application. This is more so used in research right now. So for research, mostly what they are doing is instead of having any kind of screen, they will use this light projection. And whenever your finger blocks the light, you will be able to detect that that button has been pressed. Then we have superimposition based AR. In the case of superimposition based AR, it is aiming to give you some detail that you don't have. So for example, in this example image, you can see the building has been demolished halfway, but still when you look at it, the AR will give you some details and it will show you how the building looked before the construction or before the demolition of the building. So it is able to give you some details that you don't have. So imagine it like this. You are looking at a industrial machine. You don't know at what temperature it is running. You don't know at what pressure it is running. You don't know anything related to that. But if you just look at it that, and you will get some data about it. That is how the superimposition works. You just look at a particular object, the AR mobile or AR device will scan the device and it will show you, okay, this particular thing that you're scanning was constructed at this point. It will have these features. It is using this processor. It is having this much RAM. It is running at this temperature. All those details, it will just track it automatically. So this is the highest end of AR possible. again, because it is the highest end, it is not implemented in the industry fully. It is right now in the research part. And finally, coming to the ways of using VR. So in the AR application, I told you these are 4 different types of AR. The application itself can be made in these 4 different ways. But in the case of VR, what you're experiencing can be different, but the application is always the same. So what you're experiencing is different in the sense you can either stand and play the game, you can sit and play the game, or you can walk around and play the game. So room scale VR in the sense you will have one dedicated room. In that room, nothing else will be there. You will wear the headset, you will walk around that room, you will be able to explore the virtual environment while walking around. In the case of seated VR, you will take a seat and basically have like a movie or a video. So it is mostly for entertainment purposes. Then finally, we have standing VR. Standing VR is used mostly in the industries. What we do is, let's say TVS is hiring for some employees and they want to train the employees on how to use the machinery there. They want to train them how to use the CNC machines. Instead of having to teach each and every one of them manually, they will have a VR setup. In that VR setup, when the user wears the VR headset, it will give them instructions. It will tell them what button to press, when to press, how long they should use the features, what are the features available in the headset, how to safely use the machine. All those things will be taught to them using a VR application. And that is where standing VR comes in. We don't want to walk around randomly here and there. We just want to stand there at a particular place and see how to use the machine. I'll give you examples for all these things. Yeah, we'll go into the demo videos now. Before that, if you have any questions, you can just ask me in the chat. So if you're having a IoT sample project and if you want to use it inside Unity, there is not really a specific way of doing it. There are multiple correct ways of doing it. So when you say IoT sample project, what do you mean by that? You are saying you have like a code file of microprocessor or something? And for importing the CAD models, you need to export it as a FBX file. You need OBJ or FBX. Those are the supported file formats for Unity. You either need it as a FBX or OBJ. If you are using SolidWorks or Fusion 360, after you make the CAD model, click on export. When you are exporting it, you need to select FBX or OBJ. Then you can do it. You can just directly drag and drop it inside Unity. It will work. Working with C# is fine. Visual scripting, yes, visual scripting is a bit confusing, but it is for people who don't know to code. If you already know to code, there is no need to go for visual scripting. Blender is also a 3D software. It uses any kind of 3D models, any format. For Unity also, you can mostly use many formats. The preferred format is FBX. The most comfortable format for Unity is FBX. So yeah, now we'll go into the demo applications. I'll just show you some videos. So first one is called as Operator Training Simulator. So this is a training simulation application similar to one I told you about right now. So in this case, we are going into a nuclear power plant and we want to train the employees there how to properly use it in the case of a fire or in the case of shutdown or in the case of documentation. So we are basically teaching them how to use this application.
Retarded coverall. Earplugs. Earmuffs.
So you can see the entire factory layout here. This entire thing has been 3D model accurately according to your real industry. So you can see how the steam turbines work, how all those things work. Obviously, in real life, you cannot go near them and touch them. But because it is VR, you have the functions and you have the ability to go near it and explore it. So every single thing you see here has to be 3D model. There is nothing that cannot be 3D model. So we can use any sort of software, as I told you. If you're using CAD models or CAD software, it will be hard to create inorganic shapes. Shapes like this curves or human face or any kind of curvy or unnatural structure. It is not easy to do. If it is a symmetric structure in CAD software, it is very easy. So for this specifically, we have different tools as well. We have something called as Maya and Blender. Blender is an open source software. Maya is a paid software. They are also used to create these kind of 3D models. So the user can teleport to different parts of the industry wherever he wants to experience it. Obviously, in real life, you cannot get close to this because it is way too dangerous. But here you can do it. So another advantage of this VR is whenever you want to study about a particular part, you can open its inside. You can use X-ray vision to see how it looks on the inside. So we have 3D models inside as well. So you can see how the actual wall works. This is a solenoid wall or any kind of structure. You can see the insides, see how it works, see the principle of works in progress.
Oil valve E1.
So the user is right now practicing how to open the wall. He will learn the order of operation, how to do the actual operation.
Optimizing steam valve.
He will get instructions in his ear using audio file. He also has to practice saying back the commands. So this is the entire industry layout. And he is visualizing inside the furnace, which is obviously impossible in real life because of the heat. So something like this, something that you cannot experience in real life, you're experiencing over here. So apart from this, as you can see, there is also test mode, training mode, and we are also having a technician and supervisor. So the technician will do the actual practice. He will attend the test. And based on that, if the supervisor wants to see how the technician did it, he can go ahead and see it here itself. So it reduces the practical aspect of the actual exam. Instead of having to go into the industry, stop the process of the industry, and then give them training, they can just do it in the VR application. So if you use the admin password, here you can see the supervisor can download the report of whichever class the person is in, whichever technician he wants, and whatever scenario the exam was in. All those things can be downloaded as an Excel file. So you can see here how much time the user spent, what was the issues with the user's implementation, did he forget any steps? All those things can be seen here, how long he was spending inside the application. So this is a operator training example. There is one more example for similar to that. It is in AR. So right now what we saw was in VR. So this is in AR. So again, a similar example, we are having different applications, a control valve, a solenoid valve, and turbocharger. You can choose whichever one you want. And there is a test mode and training mode for all of them as well. So this is similar to the Amazon application. You scan the ground.
Lokesh, am I audible?
Yes, sir.
Yeah, regarding that before application, we have connected that particular technician and that username and password, right? For that, do you connected any API for that?
Basically, we designed our own system for that. Yeah.
I mean, you connected any API, LLM or something for that username and password and
No, no, no.
downloading the Excel file?
No, 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 no. We can use it inside Unity itself. You can program that also inside C Sharp.
Oh, okay, nice, nice.
You don't need any sort of large language models for that. Everything can be programmed on your own. The system for logging in, logging out, along with that supervisor system, training system, everything is on the one only. Excel file also you can create it on your own and manipulate it inside a C Sharp. You don't need any tools for that externally. Yeah.
Like regarding the AML, there is like LLM, right? Gork
Yes.
LLM, like chart to voice, like that. So
Ah.
regarding that, I mean, voice, I mean, in VR, we can use that LLM as well, right? So, I mean,
Yes.
we can directly code or like can import the API key.
So that depends on the application, sir. If you are having some kind of a best use case for that AI, then it is possible to use it. In our case, it was not required, so we didn't use it. If it was suitable, we would have also used it.
Yeah, okay, thank you.
Huh. So, and one more question they have asked it. How many companies have been implemented in the VR factory? So there is not a lot of companies that have been exactly replicated. I have an example for this is one I can show you. Apart from that, we have a couple of other industries that we are working with right now. That we have recreated basically. You can find some of them examples in our website as well, Fusion VR website. So this is a 3D model of a turbocharger as I was talking about it. So inside this, you will get the audio file about the turbocharger, how it works, and you can see the X-ray vision as well. So it will show you which part is which, how the internal structure is, where the airflow is, how the fuel is ignited, all those things you can see here. So this is the next example, the same application. Now it is for the solenoid valve.
Sequential and emergency isolation services. They are also referred to as 15, HE, move, and ESDB depending on its application. These are solenoid valve, hydraulically or pneumatically controlled to their desired position necessary to deliver the required flow to a process. Now, the solenoid valve comprises of an actuator mounted on a valve body with a stem or shaft connected to it. The flow valve is special kind of valve for the automatic regulation or control of flow of fluids in a pipe. These control valves can be electrical, hydraulically, or pneumatically controlled to their desired position, necessary to deliver the required flow to a process.
Again, the main goal is the same thing. You are trying to visualize something that you cannot in real life, or you cannot do it with the books. So you want to make sure that the user is able to learn something that he cannot with the traditional methods. You are trying to drive that point home.
A control valve comprises of an actuator mounted on a body with a stem or shaft connected. The control valve, also called as the final control element, is an important element of the control loop. Control being together two important components. The control loop employs electrical signals in the range of 4 to 20 milliamps and pneumatic signals in the range of 3 to 25 pounds per square inch.
Yeah. So we'll
Yeah,
see a couple more examples as well. Yeah.
Lokesh, regarding this, I mean, there is like a turbocharger, right? I have implemented that in the AR one. So, but like there is like a plane detection, right? So plane
Yes, sir.
detection can actually the plane detection will work in the that software of I mean I forgotten that what is that uh, Vuforia engine, right? So I mean we
So
can work with the Vuforia engine as well, right? So but
yes,
coming to the Google AR Core Kit, I mean there's like a plane detection is right now working in the visual scripting part only. Like or can we code in the code for that also?
yes, we can code for that also. So Vuforia is one library that you can use for plane detection and AR features. Same way inside Unity, there is another package called AR Foundation. So that also has the same features and it is free as well. Vuforia is a paid software. Only some features are free. Inside Unity, you have AR Foundation that is completely free. That will have all the features from Vuforia as well. So you will have the plane detection, you will have marker based, markerless, all those things are there in that.
Like actually by using view for it is directly detecting the plane and it is having that particular motor, but it is taking some time while creating in the AR core kit of AR Foundation.
Yes, yes. That is because of the library difference only. Some libraries do certain things better. In Vuforia, plane detection will be better. In your AR Foundation, the marker will be better. And AR Foundation has other features as well. Body tracking will be there. So that is not available in Vuforia. So it depends. Because they are different softwares, whichever you need as per your application, you will use that. It is good to know many softwares as well.
Yeah, okay.
So these are the common examples in industry. Apart from that, I'll show you some of the projects that I have done related to the government of Tamil Nadu. So this is basically like a tribute to the Chief Minister of Tamil Nadu, former Chief Minister.
We take immense pleasure in taking you on this journey to explore the digital interactive exhibits which Fusion VR executed in less than 8 weeks at the Amma Museum in Chennai. This museum is dedicated to the late Chief Minister of Tamil Nadu, Dr. J. Jayalalitha. Amma's achievement milestones. Visitors learn about Amma's achievements by moving the needle to a specific period of her rule on digital touchscreen. This selection activates a beautiful motion graphics presentation. This high-tech interactive digital wall highlights 6 important welfare schemes that Amma successfully implemented during her rule. Visitors can touch and choose a particular scheme, and a spectacular 2D animated video describing the scheme is presented on the screen in front. It shows in great detail how that scheme helped and benefited the citizens of the state. Selfie with Amma. Using augmented reality technology, visitors can take a selfie with Amma. They need to stand at a particular spot and raise their hand to activate a highly realistic 3D animated model of Amma on the large screen in front. The picture is an unforgettable memento which can be shared to your mobile device for further sharing with family and friends through social media. Cycle travel in golden era. Virtual cycling technology is used in this interactive exhibit of Amma's schemes and achievements. Visitors mount these cycles, follow a few simple instructions, and begin pedaling. This starts their journey to learn and experience Amma's dream projects on the screen in front as they enjoy a pleasurable cycle ride. Speak with Amma. Visitors have a lifelike conversation with Amma using the virtual chat technology. Questions that visitors wish to ask Amma appears on the large screen in front and answers every question chosen. The highly realistic model immerses the visitor in Amma's aura as in a real life experience. தொட்டில் குழந்தை திட்டம்
உலகிற்கே முன்னுதாரணமான இந்த திட்டத்தை தான் ஐக்கிய நாடுகள் சபை வெகுவாக பாராட்டியது.
Glory of
So yeah.
Amma.
So the primary goal was to create a tribute memorial to the former Chief Minister of Tamil Nadu. This was given as a project within 2 months, and we completed that. Same way, recently for another Chief Minister as well, we have created a similar memorial. So in this memorial museum, apart from the normal museum structures, they will have VR experiences and AR experiences that the users can go ahead and experience. It is available for free for the people. So if you're able to visit Chennai, you can go ahead and explore that as well in real life.
Yogesh, like humans are really, or you have created that humans as well?
Those are 3D models only, yes. She has actually passed away. After death only, they wanted to create a memorial for her. So there is a museum containing her memorial.
Oh, they are all 3D objects only, right?
3D objects, yes.
Looking like real persons.
Yes. So another one example is workshops in mechanical reasons. So this is like a way how to it will teach the students or any kind of professional in a mechanical domain how to actually change the spark plug, and this is for medical simulation. This is a workshop where it will show you how to use the engine, how it's turned on, what are the parts inside that. Experiment simulation for medical purposes. Again, wherever you are having some sort of expensive equipment, you can simulate that inside VR. Yeah. Apart from that, I wanted to show you one more demo also. I'll show you the here. So I come from a mechatronics background. So in that, what we wanted to do was basically replicate all the experiments that we do in inside the mechatronics lab in VR, so that we reduce the expense for the college in the sort of equipment that they have to buy. So it will start with the one-way wiring. So in the case of one-way wiring, as you can see, the user is playing here with the VR headset. He's not having any controllers. He's using his real hands to control the things here. And when he's controlling the stuff, you can see whatever he is seeing is being telecasted over to this monitor. And I can see that particular monitor over here in bigger screen. So he will receive some audio instructions about what he has to do, where it is safe to touch, how to handle the electrical equipment, what each of the equipment does. So all those things will be taught to him first. So the instructions are not only being showed to him on the board, it is also being fed to his ears using the audio.
Let's begin by identifying the components involved in this circuit. You have a power source, a bulb, a socket, and a single port, single throw SPST switch. The goal is to control the bulb using this switch. The switch has two terminals.
So once he's caught up with all the basics of the electrical equipment, he will start with the assembly part.
Out of the way, you can now connect the other terminal of MCB to the switch.
So he has to physically use all the wires. He has to fit the wires. He has to use a screwdriver to tighten it. All those things he has to do. Because it is like in real life, if he accidentally puts it down because of gravity, the screwdriver will fall down. So it is a real life simulation basically. So again, once he does that, it will give you the next step. So you have to basically do all these steps in a sequence. Once you are at the end of the sequence, it will ask you to turn on the MCB. And we have created this as a digital twin example. So what will happen is when the user turns on the bulb in VR, the bulb in real life also turns on. So let's see now. He's turning the plug on now. So the MCB has to be turned on now. When he does that, you can see here, the light in the real life also turns on. Then it will give you some instructions about the wiring procedure in case he messes up something, what will happen. All those things will be taught to him. So this can be given to the students before they actually start the practical exam or the practical part. So they will get a better understanding of how it works, and they don't accidentally get any short circuits. So this is the first one. So the next one we can see here is robotic arm. So in this case, we have simulated a high cost robot basically. Instead of having to purchase the robot, anyway, if the college purchases, they will not give it to the students individually. So in that case, they can practice with this VR headset. So that is the KUKA robotic arm. So the user is manipulating the robotic arm, seeing how it grabs the objects, how the conveyor works.
Excellent. The bot will release the cylinder now as it has been placed on the conveyor. The belt will now move forward. Now you just have to move the robot's wrist back to the home position by following the last green cue. And then watch there in action.
So everything that the user is doing right now is being processed on the headset itself. It is not doing somewhere else. It is an inbuilt application on the headset.
You completed the pick and place task with the cooker robot. You can now proceed to the next module or repeat this task to refine your skills.
So yeah, so this module is to teach the user how to control the KUKA robotic arm, how the inverse kinematics works, how the kinematic works, how the robotic arm moves, what are the joints inside the robot, all those things. Then we have a motor simulation. So in this, the motor will be disassembled and the parts will be shown to the user. It is for induction motor.
When alternating current
So you can see a dismantle assembly.
creates a rotating magnetic field. The stator is the stationary part of the motor. Its windings generate the magnetic field that induces current.
So it is now talking about each of the individual part, what it does, how it is used inside the motor, why it is made in such a way, what is the construction of it. All those things are talked to him. Then finally, the user is given the opportunity to interact with it. He can take it in his hand. He can see how it is. He can make it bigger. He can rotate it. When he picks up something in his hand, on the blackboard behind him, you can see what is the name of that object. So this is the rotor shaft. So this is the training mode basically, in which he can just look at it and see how it fits and everything. There is a test mode as well. In the test mode, the user will be given time to complete the actual experiment within a set limit of time. Let's say 10 minutes. He will give a MCQ as well. And based on that, you can complete an entire evaluation on the VR application itself. You don't even have to conduct a practical exam. And everything is being done by hand tracking right now. So the user doesn't have anything in his hand. All the things are being tracking his hand using cameras.
Inspections are crucial. Check for signs of wear or damage, especially in the bearings and windings.
So as you can see, the motor disassembled and reassembled again. Then it is giving him some tips on how to maintain the induction motor properly. So apart from this, we have a couple more. One is a digital twin of a robotic arm. So this is a 3D printed robotic arm. And when the user is interacting with that robotic arm in VR, he is controlling the robotic arm angle, the base arm, lower arm, middle arm, and upper arm. It is similar to our elbow. So whenever you are moving these sliders here and he clicks on update, the real life bot will be updated to the same match as the virtual bot. So it is a digital twin of that particular 4D of robot. And there is a button for separately controlling the gripper. So using this robot, you can from remote areas access the robot and you can control it and pick up various objects. It is a prototype to showcase that. And then in mixed reality, when he goes into mixed reality, from his perspective, you can see he is opening the camera and he's seeing the real life now. Till now, he was in the virtual environment. Now he's in the real life. But even in the real life, he can still see this computer, this virtual computer. So that is where mixed reality comes in. Yeah. So the final one is BLDC mode. So this is the training mode. In the case of the BLDC, it will show you how the BLDC is constructed, what to do to dismantle it, what to do to reassemble it. All those things will be shown to the user. And finally, in the test mode, the user has to assemble it on his own. So let's see the test mode now. So in this case, the user is just studying about the parts. Let's go a bit more, skip to it. Yeah, here it is the test mode. So the user has to pick up the individual parts, see which part fits with which one, and he has to assemble the entire thing on his own.
Lokesh, everything you are working with the Excel grab interactable, right? Interactable and interaction to that particular one, or you are using the snap interaction?
So usually grab interactables, it depends on the application again. So when you want to place something at a particular point, for example, on this object, I want to keep this rod thing on the edge of this motor here. So for that, I will use the snap interactable, socket interactable. I want to place it in a particular point. Grabbable just ensures that you are able to take it in your hand. Once you take it in your hand, where you want to place it, depending on that, you will use the socket interactor. So this is where all the nuts in this there are grab interactables. We are grabbing it in our hand, and on the socket there is a socket interactor. So when you place it, it will basically snap into place automatically. Yeah. So based on the amount of time you spend there, you will get a grade A, B, C, or D. Then you will get a quiz mode, and you will get a 10 seconds for grading the questions, and you will get the options over there. So you have to measure you have to read the question correctly, and then option set plus the option as required. And all this data, how much time you spend here, what is the score you got, all those will be saved to a Excel file separately. The user has to log in first when the application starts. He has to enter his password and everything. Once he does that, only you will get the application. And finally, you can see the Excel sheet over there. Yeah. So on this Excel, you can verify. You will have the username password of the students. The password is encrypted. Apart from that, you will have which session they opened. So what is the actual experiment that they did and how long they spent in that. All those data measured here. So this is the primary application for engineering. Apart from that, as I said, if you are interested, you can see more of our projects in our success stories. On our website fusionvr.in, you'll be able to find us various applications. We have done projects for Government of India, Archaeological Department of India, DRDO, National Institute of Ocean Technologies, various institutes. And we are right now mostly working on animation films similar to this one, Chronicles of India. So the story of Mahabalipuram, and the ancient history of them, the ancient history of various cities as films in VR. And the Vivekananda, life story of Vivekananda, things like that. We are creating movies for them basically in VR. So apart from this, I'll just show you how we create these environments in Unity, and then we can have a final 10 minutes session related to any questions. So here, this is the same thing that you just saw, the mechatronics workshop basically. On this workshop, as you can see, we have this environment over here. So for this environment, we can develop our own 3D models if you have the skills necessary for that, or you can use any sort of assets from the asset store. So as I told you earlier, asset store is where if you don't know to do something, you can get the free resources from that. So I'll show you the website now. So this is asset store, Unity's asset store. So this website is managed by and moderated by Unity. On this, you can see 2D assets, 3D assets, audio tools. So many things are available. So whichever you don't know to do, you can just come here and get that from here. So you can see many of them are paid assets. But apart from the paid assets, there are free inputs and free assets also available over here. So what you can do is, let's say you want some city. You just search for city. When you search for it, automatically you will get this page. and you will get different types of cities. Some will be high quality, some will be low quality, some will be looking like a cartoon game, some will look as realistic as possible. It depends on your use case. Whichever you want, you can choose it. So as you can see, these are all paid ones. If you just want the free ones, you set the price to free. You will just get the free versions. So there will be hundreds of assets available here. So depending on your use case, as I said, you can use whichever one you like. So in this case, what we have is a indoor house like thing, and we have converted that to a interior structure to make sure it looks like a classroom. So if I select this object, you can see separately. This is one object. I can move this object anywhere I want.
Uh,
Yes,
Logesh,
yeah.
yeah, Logesh, I am having one doubt. So regarding this digital twin is there, right? That is called Unity 4.0. So
Yeah.
I mean, in that actually from Unity Asset Store itself, there is having like a sample project of IoT.
Yes.
So if I import that particular one, so I mean, what is that difference between the Unity and using the digital twin of 4.0, Unity 4.0? And other one is like recently Unity is launching 6.2, 6.3 and the beta versions of that particular one every time, but still the users are using the Unity 2022 only because I mean, why people are not upgrading to the Unity 6.0 and all?
So we'll come from one by one. I'll first answer your question about the version. Unity has various versions, as you said. Even myself, I would have like 3 installations. As you can see, I have Unity 6.2, 2022, and 2021. So the thing is, Unity has recently renamed everything as 6. It is supposed to be Unity 2023, but instead of naming it as 2023, they renamed it as Unity 6. That's it. The version name is only that difference. But why we are still in 2022 is because Unity 6 is recent, there is a lot of bugs. So we want to be on the most stable version. The previous versions are very stable. So we are on 2022 usually. 2022 is the most stable version before the latest update. Latest update as in Unity 6.0, 6.1, 6.2, 6.3. Unity 6 has AI features. It has a lot more features actually, but because it is not very stable, it has some bugs and everything. We don't want to risk our projects, so we are on the previous version. And coming to your question about the digital twin project, so this asset store will have one sample project for the digital twin as well, but that is a sample, as you said. It is not a implementation. It is an example. So there is various digital twin projects available here. So you can just take a look at it if you want to. But again, it is just an example project. It is not the exact recreation of a digital twin. They are giving you one way of creating a digital twin. That's all. Asset store is where Unity will release resources for learning. So they have released one resource for learning about IoT and digital twin here.
No.
Is there anything else you wanted to know, sir?
No.
Me,
So yeah, as I
me.
was saying, you are having various separate objects here. That objects you are going to manipulate using the scene navigation as well as object manipulation tools to get to the desired effect. So in this case, you can see there is a desk object, student table, and the teacher's table. There is a bookshelf. So all these things are separate objects. This is not an entire classroom as a whole. We have created different objects. We have placed them together. As you can see, this table itself is a separate object. The table itself doesn't have anything. It is just a basic normal table that I have placed in the air, so it looks like a cupboard. And on that cupboard, I have placed these books together to make it look like it is a single object. So this is how we will create our environment. So using the asset store, I'll show you how to import it as well. I'll just show you one sample asset. So whenever you're trying to get something from the asset store, you will search it for here. Let's say we want a city or a forest. Let me search for a forest. Once you search that, you will get various kind of environment like this. Some realistic ones, some tonish ones, some cartoon ones. Anything that you like, you just select that. Once you select it, on the inspector or on the website, you can see there is a open in Unity button here. By default, this button will show add to assets. Because I already have this, it is showing open in Unity. It is a free asset only. By default, this button will show add to assets. What add to asset means is it will be added to your account. Once it is added to your account, then you can click on open on Unity. Once you click on open on Unity, automatically that package will be opened inside here and it will ask you to download it. Here you can see it will ask you to download it. Once you download this package, because of internet, I will just show you a different one. I have this animals. Let me import this. Once it is downloaded, the button will change to import. If I click on import, I'll get all the things that I require. As you can see, these are the files that I have downloaded right now. Basically, this is a different package, animals. I'll show you that package. So if I search for animals in the asset store, you will get this particular thing. So this is what I have right now opened. So you have these animals. It is a cartoon animal thing. It is used for games. So if you just want to visualize how it looks inside your application, you click on open in Unity. Once you click on that, it will come here. You download it, click on import. Once you click on import, it will basically download all the models, all the materials, all the images, everything required for the package inside your project. Once this process is done, finally what you can do is you will get the models folder, right? You will get a folder basically. Inside that you will have the models, materials, images, all the things together. You just have to look through them and find what you need. And Unity has one feature called prefabs. So a prefab is basically a unique model with some custom properties applied. So let us say you create something like a cube and you put like a custom color to it. A normal cube will be white in color. Instead of that white, let's say you make it red color and you want to save it as a red color. In that case, you will create a prefab. Basically, a prefab means some object with some custom settings has been saved. So in this case, you can see once I download this folder, I get a prefab folder. Inside the prefab, I'll get this blue color icon thing. So this is called as a prefab. If I just drag it and I put it inside my scene window, you can see the model here. So I dragged the chicken model. So there is a chicken over there. So whichever animal I want, I can just drag it and keep it over there. I will get the actual model over here. So this is how we design the environment. Whatever you saw inside the videos, demos and everything, you have to create a 3D model of it like this first. Then you drag it and place it wherever you like. You can rotate them. You can make them smaller and bigger. All those things are possible. So using the asset store, if you are lacking in 3D modeling skills or anything related to this development, you can compensate for that. So in my case as well, I don't usually 3D model. 3D modeling takes a lot of time. So instead, I'll just look for assets tier and then just download them and import them inside my project and I will place them like this. So that is how this entire room was created. Whatever you are seeing inside this room has been developed like that only. So this entire room structure, the lights inside that, the chairs, desks, the board, the clock on top, everything. So
Yeah, Logesh,
yes,
regarding the camera of XR origin that is called related to the VR. So, can you make the difference between the uh, OVR XR setup and there is a like XR camera which is default from the XR plugin management, right?
yes, sir. So OVR camera rig is used for the Oculus headsets. This one XR interaction setup can be used for any type of headset, any VR headset. OVR is not used anymore actually. OVR has been, what to say, it is not supported anymore. It is not going to get any updates. It has been deprecated. If you want to use, it is recommended to use XR interaction toolkit with XR origin only. So
Now you are using the hand setup, right? Like without having the controllers, you can directly control with
yes,
the hands.
yes,
Okay, fine.
yeah. So I'm done with my session. If you have any queries, you can ask me in the chat.
Yeah, once can you play the video of a game window? What you have worked on the? I mean, it is like a buttons or like? Can you show me that? I
This
mean,
is
I
the
hope.
same thing, sir. I showed you the video now, right now, that one only. So the digital twin, the robot, the BLDC motor, all those things.
Oh, it is related to the digital twin and all. Okay, okay.
Yes,
Okay,
yes,
okay.
the same thing only.
I mean, when we click on that, it will get represent the 3D model, right? Yeah, I hope you didn't
Yes.
connect the MetaQuest. It's not an
Uh-huh.
issue. So, but we can use the XR plugin. I mean, there is like a plugin.
Simulation.
Yeah, XR simulation, right? We can
Yes.
based on that you can control, or in hand tracking it will not work.
Right now in hand tracking it will not work, but it is possible to use controllers as a simulation.
Okay, okay, fine. Yeah, yeah, understand. Thank you.
Yeah. So how to create emotional environment, as in you want to create like a environment that is able to provoke some emotions, sir? Can you be a little bit more specific regarding that? Okay. Shankar sir, the thing is, if you want to visualize something, you need to scan it using something else. Visualization is possible, but scanning the arteries and those things and all, you need the normal machinery. If you are using like the injection to inject ink onto the artery or any kind of scanning like MRI or something, that has to be converted into a VR application or a 3D model basically. It is possible to do that technically, yes, but the scanning part will still remain the same, whatever they are using in the medical industry. Yes, angiography, yes. Okay. Uh, for as a diagnostic tool, for visualization, yes, I do see it. Yes, right now, actually, in medical industries, they have started using this. In many colleges in Chennai and Tamil Nadu in general, we have a company as a partner called Medicine. They have already started implementing all these things. They are starting to use VR as a training tool for the upcoming nurses and doctors.
Like regarding, I'm having one doubt, Logesh. Actually, in medical industry, there is like one project like a human. So in that human, I mean, he used to cut the, I mean, he used to make a surgery in the hand. So can we create the layers in this part of the layers only? We can cut that particular one with the help of the physics and all.
Yes, sir, that is possible to do.
Okay. I mean, those are new. They can experience with the instructions and all, right? Yeah,
Yes,
that and
yes.
all fine.
Yeah,
But the
we just have to
my
program for
question
that.
is like in our hand there is hang like a layers of the skin and there is hang like a bone and all, right? So in the certain part only we have to I mean we have to do the surgery in that. You
Uh-huh.
can do that or I mean
Yes, sir. It is possible to train them in a particular way. If they are doing something wrong, you can have consequences for that as well. If they accidentally cut a artery of a patient, the patient will bleed out. So those things and all are possible to do. You just have to program for that in such a way.
okay. Yeah, regarding I mean Unity, they are having like a AI projects, right? We can implement as well, right? Using the some LLMs and all.
Yes, sir. If you want to have like a, actually it is already there. What I'm saying in medicine, in medicine, what they do is they have a nurse system. In that, the patient has to be talked to. You have to get the information from the patient. Basically, the patient will not give you all the details by your hand because they don't know which is important and which is not important. So the nurse has to go there. She has to talk. What is your issue? Where is your pain? And based on whatever question the nurse is asking, an LLM will give a response. ChatGPT or something using APIs will respond to the nurse. Based on the response, the nurse has to diagnose what is the patient having.
Yeah, okay. Yeah, and by the way, it is a very excellent session and the way of PPT is very nice. Showing the
Thank you so
PPT
much.
is very nice. Yeah, thank you.
Thank you. Does anyone have any queries?
Yeah, is there any recording session for this? I mean, you have recording in the YouTube.
I'm not recording on YouTube
YouTube
actually. I
link,
think Ram is also recording. You can check that.
yeah, sir. YouTube link will be shared to the participants. little late. It is actually live streaming. We'll be giving the link.
Any other queries, anyone?
Now, sir, maybe in 1 or 2 minutes, I'll just post. Still, if participants have any doubts, you can please ask this resource person. Please turn on your cameras for group photograph. I had shared YouTube link in the chat box. You can just go through this.
Thank you for your time, everyone.
Sir Logesh, sir, thank you very
Yes,
much
ma'am.
for taking your time and readily accepting our invitation to be the resource person for this 6-day online faculty development program and augmented and virtual reality principles and technologies. We thank you very much for your valuable time, sir. You have given very useful insights into this grand program. And
Sir, hello,
I think many
hello.
participants have got good knowledge about this program.
Yes, ma'am. Thank you.
Thank you, sir. Thank you very much.
Hello,
Ah,
sir.
sir, tell me, sir, you have some doubt?
Yes, sir.
Yes, sir.
If we want to build the artificial augmented personality, moving like someone who died previously, grandparent like that. If we
Yes.
want his augmented reality character moving in publicly, what is required, sir? What is the minimum amount for technology?
So minimum amount in the sense you want to know the processing requirement or the price?
No, just we listen that Modi's hologram is there giving speech like that. Some he is there at one place and it is giving in other place. And in Hollywood movies, we have seen these characters, artificial characters. So, what is required basically for that?
So
Is
you
it
don't need
one indoor
much.
studio required or open place
Yes, sir.
also it can be done?
It can be done anywhere, sir. You don't need anything in particular. You just need a
Mm.
screen or something. If you have a screen, you can just project any kind of AR feature in that. If you don't have a screen also, I showed you one thing called projection AR, right? So that is like basically
Mm.
hologram. That is not in the
Yeah.
company or not in how to say, that is not in production as much for commercial purposes, but still it is in research. So in case of doing that, it is possible to do it.
Okay. So minimum cost how much, sir? Any approximation?
Depends on the application, sir. For example, if you just need a model that talks, you can do that within 20-25 lakhs, sir.
Mm. Sir,
Creating a
in
realistic model.
cartoons also.
Cartoon is easy. If you want realistic only, it will be harder.
So in cartoons, to build a character, it takes several days, sir. But by using Gen AI and LLM tuning, can we reduce it?
So for diagrams, yes, but for 3D models, there is not a good enough Gen AI right now. Gen AI is only useful in 2D images. For 3D, it is not yet good enough.
But in future, possibility there.
Yes, sir. Future possibilities there, obviously.
Okay. So your email ID, please.
I'll share it in the chat, sir. Yeah, I've shared it in the chat. You can take it from there. Anything else, anyone?
Dear participants, still if you have any doubts, please you can ask.
Sir, can we make Michael Jackson or Savitri to act again or to give program in future?
Yes, sir. It is possible.
But I heard, sir, that, sir, in America or in Canada or in topmost studios like Disney, there are so many AR, VR, and editing tools which are not spread and kept secret. Otherwise, if they are open, a common man can develop Hollywood type of movies or incidents with a low cost. I heard it from one multimedia expert. Is it true?
It is kind of true. It is not as much of a secret as in we don't even know it. We know what they have. It is just hard to recreate what they have. Disney animation movies, no, most of them are using these kind of tools only. The amount of technology they have put into this is much higher than what the world has actually. You can actually see them if you go into Disney World. It is like a theme park in USA. If you visit there, you can see all the technologies that they use, but they don't tell how they make it. You can use it and see, but you don't know how to manufacture it. Shall we wind the session, or is there anyone else having any doubts?
Sir, I think maybe it required expensive hardware. Someone is writing in the chat.
Yes, yes. So the overall cost of this, depending on the hardware, will be very high only compared to normal programming. Because you need to have a higher processing power, you need a good GPU. Your cost of implementation will be higher.
Okay, participants have no doubt. We'll wind up this session. Thank you once again, sir. Thank you very much for your valuable time. And
Thank you, ma'am.
good night, sir.
Yeah. Thank you, everyone.
Thank you, sir. Dear participants, do we have someone? I think, sir, is there? Do we have any cloud-based engines to reduce cost? It seems.
So not really, sir. Because it is even for a normal GPU, it is hard to run this application. So there is no good enough cloud network right now. Everyone uses a 4090 or a 5090 GPU right now, and uses that engine to run it on the local GPU only. Cloud GPUs are just not good enough, or they're not cheap enough, I guess.
Sir,
Thank you, sir.
if you don't mind, sir, hello.
Yeah.
Can we make these 2D movies into 3D movies? Old our marriage videos or family videos.
For that, you need Gen AI only, sir. Right now, they are developing Gen AI for that only. We can give 2D images and the 2D images will be converted to 3D. Gen AI is doing that right now, but it is not good enough.
What I heard, sir, for making a 3D, all cameras should be in, surrounded that man or that personality. Then only we
That
can
is
make a 3D model. Is it true?
that is the normal way of doing it, yes. So what we usually do in industry right now is we have around 10 cameras looking at the same point of view. Let's say 1 meter square, 1 cross 1 square. In that square, a person will be standing. 10 cameras will be pointed at him. One will be from the top, one will be from the right, one from the left, one from front, all directions. In that case, what will happen is you basically will get a different angle. No, all those angles will be converted together into a 3D model by one algorithm. That is the normal standard way of doing it in the industry. For movies also, they do the same thing. Because you are talking about a 2D image, you right now have only one image. To convert that image to 3D, you use Gen AI right now. But it is not having that many features. It is not good enough. But it is technically possible to do it.
Thank you, sir.
Thank you. Any other queries?
But I think no more questions. So we'll wind up for today, sir.
Sure, ma'am. Thank you so much. Thank you,
sir.
everyone.
Thank you, sir. Thank you. Dear participants, the feedback link is already shared. I hope most of you have filled it. If it is done, we'll just wind up the session. I'll wait for 2 more minutes so that you can fill the form. Madam, I'm winding up. Dear participants, we'll meet tomorrow at 6 o'clock.